I am Dr. Vanilata from Department of Chemistry, Maristella College, Vijayawada, Andhra Pradesh. In this video, I would like to discuss about the nomenclature rules that are applicable to name the coordination complexes or coordination compounds. By the end of this video, students would be able to describe anionic, cationic and neutral complexes. They would be able to apply nomenclature rules and write names for the given complexes. Let us look into the different types of complexes and how to name the complexes. Complexes are broadly classified into two types, non-ionic complexes and ionic complexes. Non-ionic complexes are those complexes which do not produce ions when they dissolve in a suitable solvent. They remain in molecular state. That's why the name molecular complexes is also given. As they do not carry any charge on them, the neutral complexes name is also given. Coming to ionic complexes, they carry charge on them. If they carry positive charge, then the complex ion is a cation and the respective complex is known as cationic complex. If the complex ion carries negative charge, then the respective complex is known as anionic complex. Now let us look at the nomenclature rules that are applicable to both the non-ionic complexes and ionic complexes. Non-ionic complexes or neutral complexes are given single word name in the following format. Name of the ligands in alphabetical order followed by name of the metal atom with oxidation number. And the entire content must be given as a single word. It must be expressed as a single word. Coming to ionic complexes, the following syntax is followed. Name of the cation followed by name of the anion with a single space in between them. Whatever the type of the complex, whether it is anionic complex or cationic complex or neutral complex, we should learn the rules for naming the coordination pair. Why? Because coordination pair contains the metal atom and the ligands directly attached to the metal atom. These both together is known as, when considered as a single entity, and is known as coordination pair. So if we know the rules for writing the coordination pair properly, then we can write the name of the entire complex very comfortably. Now let us look at the rules for naming coordination pair. Rule 1. The ligands are named first followed by metal atom. This coordination pair contains both ligands and metal atom. We have to name the ligands first followed by metal atom. While naming the ligands, we have to look at which type of ligand it is. For example, while naming the ligands, we have to consider the type of the ligands. Ligands are broadly classified into three types: neutral ligands, positive ligands and negative ligands. Neutral ligands do not carry any charge on them. Positive ligands may carry positive charge and negative ligands carry negative charge on the donor atom. Right? While coming to the naming part, the neutral ligand is named as it is without spaces. Positive ligand's name must end with em. Negative ligand name must end with o. These are the rules related to naming of the ligand. Positive ligand name must end with em. Negative ligand name must end with o, whereas neutral ligand name will not be changed. It is written as it is. Some examples are listed here regarding with these three types of ligands: neutral ligands, positive ligands and negative ligands. This slide consists of neutral ligands. In certain cases, certain neutral ligands are given special names, like ammonia. Ammonia is given as amine, water is given as aqua or aquo, NO is given as nitrosyl. When these compounds functions as ligands, then their special names are given. And coming to this part, CH3 tris SO, dimethyl sulfoxide, urea, pyridine, terpyridine, ethylene diamine, etc. These are given their original names while naming them. This is the list of anionic ligands. We know anionic ligands name must end with O, right? So Cn minus, F minus, Cl minus. For example, Cn minus, if you take, its original name is cyanide ion, but when it functions as a ligand, its name must be given like this, cyano, means here O is given. Name of the negative ligand must end with O. Cyano, fluoro, chloro, bromo, iodo, like that. So when these ligands are, when these groups are inside the coordination sphere, we can understand that these are functioning as ligands. When they are functioning as ligands, their name must end with O, being they are anionic in nature. Okay. Certain other list is given here. The acetate ion, its name is changed to acetate-O. Sulfate ion, when it functions as a ligand, its name is changed to sulfate-O. Carbonate ion, as a ligand, name changed to carbonate-O, and so on. This is the list of cationic ligands, and we learnt the name of the cationic ligand must end with em, NO2 plus is given the name nitronium, NO plus nitrosonium, hydrazinium, hydronium, etc. So let us summarize how to name the ligands. Ligands are of three types. Neutral ligands are given their original names. Certain neutral ligands are given special names. Next, cationic ligands are, the name of cationic ligands must end with em, and name of negative ligand must end with O. Now let us look at the rule 2. If the coordination sphere contains several ligands, then they must be listed in alphabetical order. You have to look at different types of ligands and observe their names and put them or write them in alphabetical order. That is the rule 2. Next, rule 3. If same type of ligand is present more than once, then the name of the ligand is prefixed with the words di, tri, tetra, etc. These prefix words di, tri, tetra, penta, etc. Are used. Suppose, say, here we can see a special case. If the name of the ligand itself contains the prefix words like di, tri, tetra, for example, ethylene diamine, if you take ethylene diamine, the name of that particular ligand contains the prefix word di. In that case, we should not use these ordinary prefix words. Rather, we have to shift to a special prefix words like bis, tris, tetrakis, pentakis, and so on. Okay. In this case, the name of the ligand should be placed in parentheses. Now we finished how to name the ligands, different kinds of ligands, and whether it exists a single type of ligand or different types of ligands, alphabetical order, etc. Certain rules we learnt about the naming of the ligands. Now let us move on to how to name the metal atom. Right? Before naming the metal atom, we have to observe which type of complex it is, whether it is anionic complex or cationic complex or neutral complex. By making out the type of the cation, then you have to apply this rule 4. For neutral and cationic complexes, the name of the metal atom will not be changed. For anionic complexes, the name of the metal atom ends with 8. Right? For neutral and cationic complexes, the name of the metal atom will be written as it is, means without changing any its name. For anionic complexes, the name of the metal atom ends with 8. After writing the name of the metal atom, we need to write the oxidation number of the metal atom in Roman numerals within parentheses. Right? So these are the rules how to name the ligands and metal atom. Once we apply the rules properly while naming ligands and metal atom, then we will finish writing the coordination sphere. And whatever the species that are present outside the coordination sphere are known as simple species or simple ions, which will be named with their original names. Whatever the rules that we learnt will not be applicable to the species that are written outside the coordination sphere. Let us apply these rules for the first example. CONH3 5 times, CO3Cl. In this, let us observe what are the contents written within the square brackets. So, the contents written within the square brackets come under coordination sphere. Right? So, here in this first example, I find metal atom cobalt and ammonia, 5 groups, and carbonate ion, right? Here the metal atom, central metal atom is cobalt and the ligands are ammonia, carbonate ion, right? As we know, ammonia is a neutral molecule and it is given a special name like amine, okay? And carbonate, CO3 2 minus, it is an anion. So carbonate is anionic ligand and ammonia is a neutral ligand. So for neutral ligands, the names are written as it is or with some special names. For anionic ligand, the name must be end with O. That's why this carbonate ion name is changed to carbonato. And this amine, ammonia molecule name is changed with amine. And we find here ammonia molecules are 5 in number. This number 5 is represented with the prefix word penta. So the name comes as it is pentamine. Pentamine. When together mixed, it comes out as pentamine. And this is carbonato. When I list the ligands in alphabetical order, amine comes first, followed by carbonato. So pentamine, carbonato. With this, we finish naming the ligands. Now let us move on to naming the metal atom. While naming the metal atom, you have to make an observation that whether this complex is ionic complex or neutral complex, whether it is cationic complex or anionic complex or neutral complex. It is very clear that this is a cationic complex. How can you find that this is a cationic complex? Why? Because here outside the coordination sphere, chloride ion is written. So the counter charge must be carried by this coordination sphere. Chloride ion is anion. Therefore, positive charge must be carried by this coordination sphere. Therefore, the complex ion is a cation. So in that way, you have to identify the type of the complex. So when it comes to rule 4, cationic complex, in the case of cationic complexes, the name of the metal atom will not be changed. Therefore, the cobalt name is written as it is. So pentamine, cobalt, pentamine, carbonato, cobalt. Next, when we calculate the oxidation number, it comes out as a 3 and which is written here in Roman numerals within the parenthesis. So pentamine, carbonato, cobalt 3. And chloride is the name of the species that is written outside the coordination sphere. These nomenclature rules will not be applicable to simple ions. So the entire name now comes out as pentamine, carbonato, cobalt 3, chloride. So here complex ion is a cation and this chloride ion is anion. So cation and anion are separated with a single space here. Okay, pentamine, carbonato, cobalt 3, chloride. In the similar way, the rest of the examples are also can be answered. Next, rule number 4. If the complex possesses water of crystallization, then the name of the solvent is written at the end of the complex. The number of solvent molecules must be expressed in Arabic numerals. For example, this cobalt H2O 4 times Cl2 Cl 2H2O. Here this 2H2O comes out as water of crystallization. In that case, you apply the rules as it is what we learnt in the previous slides, as it is to name this entire complex followed by this suffix 2 water. So tetra aquo dichloro cobalt 3 chloride 2 water. Next rule is if a complex rule number 5. If a complex ion has 2 or more metal atoms, then the ligands connecting these metal atoms are called as bridge ligands. The Greek letter mu is written before name of each kind of different bridge ligand. For example, here a bridge complex is given here. Iron is linked with 4 water molecules, and here iron is linked with 4 water molecules, and these 2 iron metal atoms, central metal atoms, are bridged with 2 OH groups. SO4 twice, which is written outside the square bracket, is a simple ion. So its name is given like this: octaqo. Octaqo means these 4 water molecules, together 8 water molecules. H2O is given aquo name. Therefore, octaqo, mu. Why I have written mu here means it is a bridging ligand. So mu dihydroxo diiron 3 sulfate. If the ligand contains more than one donor atom, its point of attachment with the central metal atom is designated by the symbol of the donor atom after the name of the ligand. The example is given here. So these are the practice problems that you can work out, and this is the answer key for that. Thank you so much.